Okay, so let's talk about uncertainty and the significant figures. So all measurements have uncertainties. The uncertainties in a measurement depends on the limitation of the measuring device. For example, a meter stick versus micrometer caliper. So micrometer caliper can measure in finer detail than meter stick, right? The uncertainty in a measurement is indicated by the number of significant figures. That's the digits that are known with certainty plus the one digit that is estimated. For example, let's take a look at this paper clip, and you have a ruler here. It measures, the little one is millimeters. Then so here's 1 centimeter, 2 centimeters, 3 centimeters, and so forth. So how long is this paper clip? So you know for certain it's about 2 centimeters and 3 millimeters, 2.3 millimeters, definitely between 2.3 and 2.4. And over here, you have to estimate. So this part is the estimated. So with the significant figures, you can say that paperclip is 2.32 or 2.31 or 2.33. This measurement states that you are certain that paperclip is at least 2.3 centimeters long, but it is a little bit longer than that. So you estimate the last digits to be 0.2 millimeters because you can only read up to millimeters, right? Or 0.02 centimeters. So that's why it's 2.3 plus 0.02. That's how you got 0.32 centimeters. So the limitation of this ruler is millimeters. So you can only guess the length when it is less than 1 millimeter. Significant figure, there are rules. So when you're given a number, you're supposed to figure out how many significant figures is in that number. So the first one, let's see when the digit is not 0, then all the digits are significant. So this one has 4 significant figures. But when digit is 0, it has 3 cases. First, any 0 between non-zero are significant. And leading zeros are not significant. Take a look at first number. You have leading 0. Leading 0 means there is nothing in front of 0. 0 is the starting. In this case, the leading 0 is not significant, so this number has only 3 significant figures. On the other hand, this number has how many leading zeros? There's 5 zeros. They are all leading zeros because there's nothing but 0. Right? So all these zeros does not count. So you'll have only 1 significant figures. 0 between the numbers, those are significant. So this 0 also has 0, but these are not leading zeros because there is a non-zero in front of 0. So all these zeros between the numbers, between non-zeros, are significant. So all the numbers are significant. In this case, this one has 5. How about this one? So they have 2 zeros. 1 0 is between the numbers, so this is significant. But this number, this 0, that's a leading 0. Leading zeros are not significant. So this 0 is not significant, but this 0 is significant. So total together has 3. So this is 0 between non-zero, leading 0. Next one, we have to talk about ending 0. There's 2 scenarios for ending 0 to see if there is a decimal point. If there is a decimal point, zeros are significant. Okay, so this is talking about ending 0. So ending 0. Okay, and this all ending zeros. There is a decimal point. So that means zeros are significant. All these zeros are significant. So there are 4 significant figures. And how about ending 0? There is only 1 ending 0. All these zeros are the leading zeros. Leading zeros are not significant. Ending 0, since there is a decimal point, so ending 0 is significant. So there are 2 sig figs. If there is no decimal point for ending zeros, again, we're talking about ending zeros. If there's no decimal point, then zeros are not significant. Take a look at this number. There's no decimal point. All these ending zeros do not count. So this has only one suffix. There's one ending zeros. Again, there's no decimal point. This one also has one suffix. Okay. How do we determine the figures in calculations, significant figures in calculations? So there are basically two types of calculations, right? One, multiply or divide. In this case, the result has no more significant digits than the least precise of the original number. Take a look at original number. There you have three numbers. The first number has 3 suffix, the second number has 2, the third number has 4. So the least one has 2, so your answer should only have 2 significant figures. Take a look at the next number. There's two numbers. The first number has 1, 2, 3, 4, 5, 6 significant figures. This all non-zeros. All of them are significant. The second number has 3 significant figures. So which one has the least one? The second number has 3, so your answer should only have 3 significant figures. This is for multiplying and divide. How about when you add or subtract? When you add or subtract, it's important to line up the decimals. You gotta line up the decimals. The result is determined by the number with the largest uncertainty. That means the fewest digit to the right of the decimal point. You have two numbers. Which one has fewest digit to the right of the decimal point? It's 138.2. This one has up to the thousands. This is only up to the tenth. So this is the one has the least. So you'll have to cut it off right here. Right over here. But you look for next number. If the next number is a 5 and over, you'll have to carry over. So it becomes 165.4. Okay, the tests and exercise in the textbook. The test, including AP test, assumes there are 3 significant digits, though. Next one I do want to talk about is sometimes we have to use scientific notation to express significant figures. So uncertainty can be shown in scientific notation simply by the number of digits displayed in part A. Remember, scientific notation is A, then times 10 to the n. So whatever number in front, that tells us the total number of significant figures in this. For example, if you have 1,000, there is 1 significant figure. How do I express 2 significant figures with 1,000? I have to use scientific notation, which is just 1.0 times 10 to the 3. Remember, ending zero is significant when there is a decimal point. This number tells us there's 2 suffix. How do I express this with 3 significant figures? I simply put 1.00. For 4 is 1.000. Okay, that's 4 significant figures. And let's take a look at this example. Okay, so the rest energy is this. Use this equation where C equals to this. Look how many significant figures. And we know mass, mc squared. E equals mc squared. Mass, in this case, only have 3 significant figures. Remember, you take the one with the least amount. So this one has 3, so your answer should only have 3. Next question, the density is mass divided by volume. So we know mass has, in this case, has 3 significant figures ending 0 with the decimal counts. This one has 2 significant figures ending 0 with the decimal counts. So since this is a division, mass divided by volume, so your answer should have only 2 significant figures. So which one has 2? B has 2. Okay, so that's the one. And that's significant figures.